Picture a major enterprise signing off on a massive digital transformation project to replace its aging infrastructure and stay competitive. But almost immediately, the wheels come off, budgets double, deadlines vanish, and worst of all, tweaking a single line of old code takes down the entire payment processing system. This happens because the team broke a cardinal rule of engineering. They started altering a deeply complex system without a clear map of how it actually works. Diving into a legacy codebase blind directly threatens daily operations, creating a cascading vulnerability that affects the entire business. This matrix represents a typical enterprise architecture. Across industries, more than 40 locked inside that tangle are millions of lines of code dictating sensitive data flows, strict compliance checks, and core business rules. The entire organization relies on this machine to execute its most critical daily tasks, yet no one actually knows how it makes its decisions. When leadership realizes they need to see inside the black box, their first instinct is pulling engineering teams aside, asking them to manually document the code. For a system of any real size, that process consumes thousands of expensive hours, stripping top talent entirely away from building new features. And even if they finish, the work suffers from immediate decay. Look at this relationship between a code block and its documentation. The exact second a developer pushes a new update to the system, the manual record becomes entirely obsolete. Teams are left relying on outdated internal wikis, creating a false sense of security that guarantees costly mistakes during a migration. To upgrade safely, complete visibility into system behavior must be established as an absolute requirement before writing a single line of new code. Think of it like physical architecture. You would never demolish a wall in a high-rise without a precise blueprint showing exactly where the load-bearing beams are located. To survive a major digital transformation, extracting the exact logic of the old system must happen before altering the new one. Here, a model called living documentation takes over, powered by an AI system known as Code-Aura. Rather than relying on manual data entry, Code-Aura integrates directly into the environment, reading millions of lines of legacy code entirely on its own. This diagram illustrates the extraction process. The AI instantly translates unreadable legacy scripts into clean, perfectly structured flowcharts and human-readable business rules. Because it is embedded directly in the workflow, the documentation updates in real time, the moment the codebase evolves. The system record stops acting as a passive, decaying file and becomes a continuously accurate operational asset. With this active map in place, the guesswork of modernization disappears. Engineering teams finally have a clear view of every hidden dependency. We can see exactly how this works in practice. A developer can query the system before making a change and instantly identify exactly which business rules will break downstream. This shared queryable interface bridges the historical gap between the developers executing the code and the executives managing compliance. The sprawling, untrusted legacy environment is converted into a fully transparent platform of actionable intelligence. System knowledge must be treated as critical infrastructure, carrying the exact same priority as server scalability or cybersecurity. Pumping millions of dollars into modern tech stacks yields little value if the organization cannot see or understand the foundation it's building on top of. By using AI to comprehensively document and map legacy code first, enterprise teams eliminate friction, reduce deployment risk, and rapidly accelerate their overall timeline. Moving past outdated systems doesn't require taking a blind leap of faith. By achieving total system visibility first, enterprises can build a highly secure, high-speed path directly to the future.